In this video, we're gonna use the principle of mathematical induction to prove the following result. We have A, the matrix that's defined by 1, 1, 0, 1. We want to prove that A to the power n is 1 and 0, 1. And n is a natural number. The key idea here is that we want to follow the conditions to get this result here. Okay, first we note that if we let a to the power 1, we see that a is itself in this case. Okay, this means that this property is true for a equals 1. Okay. Next, we assume that we have the following. We assume that a to the power n is 1 and 0, 1. And we need to prove that a to the power n plus 1 is 1, 0, and plus 1, 1. Okay? So here we prove that this property is true for n equals 1. We assume that it's true for n. That means we assume that a to the power n is written in this form. And we need to show that it's in this case. A to the power n plus 1 is 1 n plus 1, 0, 1. Okay? By definition, we have a to the power n plus 1 is a to the power n times a. Okay? And this means that we're going to use what we have, the hypothesis that we have here about a to the power n. So we have 1 n 0, 1 times 1, 0, 1. Now we use the product, okay? The product of matrices to get the result here. So we have 1 here, and after that we have 1 times 1 plus n times 1, which is n plus 1. And here we have 0 times 1 plus 1 times 0, which is 1. And we have 0 times 0, 0 times 1, which is 0, plus 1 times 1, which is 1. Okay? And this means that a to the power n plus 1 is written in this manner. Okay? This means that it's true. Therefore, by the principle of mathematical induction, a to the power n is 1 and 0, 1 for all n bigger than 1. Okay? So using the conditions, we conclude that a to the power n is 1, 0, or 1 and 0, 1. This means that a to the power n can be written in this form for n bigger than 1. Okay? This means that this property is true for all n bigger than 1. Thank you.